welcome to everybody who's joining us, either live or if you're watching this on the download from the website. My name is John Holtz. I'm the current technical director of Incozy UK. And today, this is the first year that we've done this, but it seems to be getting a good reception. It seems to be working well. Is what we're doing, we're giving the people that have the reserve papers from last year's ASEC, so from ASEC 2021, the opportunity to present their papers to an audience, obviously using Zoom rather than live. This will be recorded and it will be available afterwards. If people have questions, can they please type them into the chat facility, and then I'll take questions at the end. We've got three presenters today, all from, well, two from Costain, one retired, I believe, Keith.
Yep.
From Costain. The title of the paper is Making the Technical Processes Work for You. And our three presenters in no particular order. We've got Alexander Hill, who graduated from Loughborough University. He's one of those rare people with an actual qualification in systems engineering, which you have to be below a certain age to have one of those. He joined Costain in 2020. So the probability of him actually having met anybody face to face in Costain is very slim at the moment. So welcome, Alexander. We're looking forward to that. Dr. Keith Collyer, who you know, a familiar face at Incozy UK events, retired from Costain, which begs the question: what on earth are you doing, spending your precious leisure time talking to us on something like this? And then finally, we've got Liz Wright, who's been working at Costain, and he's focused primarily on HS2. So we know who to blame now for that kind of thing.
Thanks.
So what I'm going to do now is hand over to Keith. I believe you're doing the introduction. The title of the paper is Making the Technical Processes Work for You. And it's concerned with looking at some of the technical processes in 15288 and hence the Incozy handbook. And really, you know, what's the purpose behind them? How do we use these things effectively?
So thanks very much, John. So yeah, this work came out of when I was still at Costain. We had started a set of meetings amongst the team, as much as anything so people spoke to each other, because with the absence of face-to-face working, it was quite difficult. So some of them, we had daily meetings, and once a week we would take a look at the Incozy handbook and 15288, and basically working through the handbook, looking at each of these processes. And as we were going through them, I had a realization that the purpose, at least as expressed in the handbook, is a bit clearer in the standard, to be honest. Wasn't always that obvious for each of them, but in fact, and as you'll see as we go through this, I don't want to preempt the whole paper, but there were some significant statements we could make about each process and about the processes in general, and what they're doing and why we need them. So I will stop talking for a while now. I'll hand over to Liz, who's going to do the lead-in. No, sorry, Alexander is going to do the actual technical lead-in. I should have read my script. And Liz is driving the presentation, and she does know which buttons to press when. Thank you. Alexander, over to you.
Thank you, Keith. So ISO 15288 and the Incozy Systems Engineering Handbook define technical and other processes, but they do not really explain why we need them all. So why do we need all these technical processes? Well, we need them because they enable us to do one thing and do it well. Here we have an apple as our system of interest, and we can enact a technical process on the apple, which is called eating. We can formalize this technical process in terms of state changes. So the initial state change of the apple is uneaten, and the final stage is eaten. The technical process provides the method of transforming from one state to another. In this case, a state change is necessary to provide nutrients to an individual or primary stakeholder within this system of interest. So by defining the state changes, we can clarify the need for each of the technical processes on a sound philosophical footing. When we define what changes in the understanding of the system of interest, we reduce confusion about exactly how the processes differ. This is particularly useful for us and to those without a systems engineering background who are trying to get to grips with the differences between processes. For instance, the differences between the architecture definition and design definition process. So the standard ISO 15288 defines purposes for each process that focuses on how to do the process, but not necessarily on the outcomes. Hence why the process which has value that can get lost. This leaves us to ask why. why do we need to do this? What do we gain by doing this? There seems to be things missing without being able to actually put a finger on exactly what. With 14 technical processes and a total of 30 distinct processes defined within the standard, it's not surprising that people can get confused about them and what they all are for, and the sometimes subtle differences between them. This is perhaps particularly important when you've got different organizations and different processes, when you've got different processes or different parts of the system being worked on by different organizations. For example, an organization in the construction industry might use the implementation process while delivering actual construction, and we may contract out the design definition process to a design house. So we will not necessarily be involved or aware of the processes and steps used to reach this point. Many engineers, program managers, and project managers find it challenging to understand why they cannot skip or combine processes. In particular, the architecture definition, design definition processes are often confused. In our perspective, the distinction is clear, as the two processes increase the maturity of the system or the maturity of the information about the system in different ways. The architecture definition process makes a state change in the abstract definition of system elements, and the design definition process makes a state change from that abstract definition to a concrete definition. For simplicity, in the following, we will refer to the maturity of the system to include information about that system. So, looking at a specific example, does anyone actually understand what the system requirements definition process does from its definition in ISO 15288? The definition is, the purpose of the system requirements definition process is to transform the stakeholder user-oriented view of desired capabilities into a technical view of a solution that meets the operational needs of the user. So the start point is, it's fairly clear, but the phrase technical view of a solution would equally well, it would fit within architecture or detailed design. So what does it actually mean? What do we need to do to carry out this process, and what changes when we carry out this process? The actual outcome of the process is a definition of what the system must do to meet the needs, but nowhere is that made clear in this definition. If you call it the spoiler, this process, as with all others, changes the level of the maturity of the system. Our approach provides solid grounding that clarifies why we need this and all the other technical processes.
This question of why all these processes, and the discovery of some unanswered questions, started us thinking about and discussing the relationships between the processes, with particular reference to the ISO standards, not just 15288, but some of the others. These can be a bit dry, so we thought a picture of a waterfall might make it easier to digest. The system progresses through a set of lifecycle stages in which information, a record, or an artifact might be developed, as defined in ISO 12207. The state of the system can be determined for each lifecycle stage for concept development, production, utilization, support, and retirement. These stages can occur independently, as overlapping stages, or concurrently with one another, depending on the lifecycle model that has been adopted. Typically, at any time, various parts of the system will be in different states up to at least the system being operable, and even beyond. ISO 24748-1, there's lots of these numbers, states that the relationships between the processes are only static. The more dynamic, real-life relationships between the processes, between the parties, and between the processes and the parties are established when the appropriate document is applied on projects in a manner specific to that project. So we started thinking about the processes in this way and the resulting relationships between them within a life cycle. So we started to look at the technical processes from the INCOSE handbook and the ISO standard using this view, and we started looking at them as a flow to see what we could learn. Just to be clear, we do not advocate that the technical processes are sequential or that all of them need to be used. This was a thought exercise intended to learn more about the processes. When you do think about it as a flow, and using the flow as a view through which to examine the systems engineering processes, we came to realize that a state change, equivalent to a change in maturity of understanding, occurs between the entry and exit point of each specific process for the entity, whether that's the system, the subset, or the element that goes through that process. and that it is only the processes that make these changes. The system and the information about it is static between the processes. To represent this thinking, we map the flow onto a state transition model, where the boxes represent states and the arrows represent transitions between those states. For the most part, these states apply to parts of the system, not to the entirety. For example, some parts could be implemented, while other parts are still transitioning to defined stakeholder requirements. Within these limits, you could even have some parts of the system being disposed of, while others are having their scope defined. Thinking about a wing of a hospital that's being demolished to make way for a new treatment facility. So, to repeat, we looked at the processes through the controversial view of a flow, but through that we have discovered that things only change to the system and about the system within the technical processes. And in this context, it makes sense to consider the general guidance that any process should do one thing and do it well. We have identified that the one thing that each of these processes does is to change the state of the system, or more typically the state of the information about the system. This is not in the main the state of the entire system, just the part that goes through the process. In a general sense, each of the technical processes increases the maturity of the system through a state change. The purpose of this work is to formalize the technical processes in terms of the state changes that each process enacts and why these state changes are necessary.
So before I go through this table, and I'm not going to go through it in detail, please do not try to read it. It is worth having a look at, but it's in the paper and we're not going to go through every single line item in there. So what we're looking at here is a table where each row represents one of the processes. Well, I should say that we are not taking into account the analysis process here, and the reason for that is that's more of a support process to all of the others rather than something as part of the flow. The sharp-eyed overview would have noticed that it was missing from the diagram Liz just presented. But we're looking at various aspects of each process. So firstly, what the focus is of the process, and because this is key to our thinking here, what state change the process enacts. What's the difference between the entry and exit? We're looking at the domain of each process. Is it around about the problem or about the solution? And we're looking at the level of abstraction for each process. Is it working on abstract concepts or concrete things? And using these attributes that we're looking at, we can see that each of the processes increases the maturity of the system. And as Liz mentioned earlier, by maturity of the system, we could be talking about part of the system or the whole system, by bringing about a change of state, and again, for either the whole system or a part of the system. When any of these attributes changes, it's a change of state. We use as an example through this the distinction between architecture definition and design definition, because as Alexander mentioned earlier, these two are often confused. But if we look at what's actually going on in each of these processes, we can see that if we look at the state change, what's actually happening here in the state change in the architecture definition is we're translating from effectively describing what the system does. It's a set of verbs, which is the system requirements. We're taking the system requirements, which essentially define functions, verbs, and we're turning that into a set of nouns, things. But these are still abstract. They are not detailed, concrete descriptions of things. They are abstract concepts, and we'll give an example in a moment. The design definition, on the other hand, takes these abstract nouns and turns them into something much more concrete. Both of these increase the maturity of the system. These are both state changes, and they're increasing the maturity of the system, or strictly, I guess, in this case, the maturity of the information about the system. And when we move on, we can see that in the particular example, the architecture definition we've chosen in this particular case is that we want to have a heat source below some pans. That's our architecture for cooking something. So we need to cook something, we need to heat it up. Heating is the verb, but what we're going to do, we're going to provide heat source below pans. And then the design decision says, well, what type of heat source is it? Well, let's choose induction heating. And that in turn implies particular types of pans. Now, induction heating and particular pans is much more concrete. These are real things. We can go out and buy an induction heater. We can go out and buy suitable pans for that. If we just want to buy a heat source, that's too vague. Doesn't tell us enough. Are we buying a gas heat source? Are we buying an electric heat source? Is it a radiator? Is it convecting heat, or what is it? So we need much more definition, which is what we get with the design. And that, to me, one of the main benefits we found out of this whole process is it really clarified to me, and I've been doing this for 30, 40 years, clarified the difference between architecture definition and design definition in a way that had never happened for me before until this realization came about. So that's when we thought we've got something here, there's something important to say about this. Okay, so I'm going to hand over now to Alexander to carry on and talk about conceptual gaps.
Yep. So another question for you. Why do we need so many processes? Well, in all but this actual simplest of cases, going from defining the problem in the abstract to defining the solution in the concrete, like we saw with the architecture and design, it's too big a conceptual gap. If you try to bridge too big a conceptual gap, you risk losing the ability to see meaning in the connections. So if we look here, we have an apple and an apple tree. Well, how do we get from one to the other? Like with the previous example, we start by eating the apple, then we can extract the apple pips to plant them. The seeds will germinate and grow, and with some care from a human, until a point where we can plant the sapling and let Mother Nature take over from there. And then the sapling will grow into an apple tree over many years. Even in this simple example, we can see that we need discrete processes that each do one thing and do it well. And only with the combination of these processes do we end up with an end result of an apple tree. Without the technical processes, we could not bridge the gap between apple and apple tree. A related question is, why do these different processes result in different approaches and outcomes? Well, each process moves the understanding and development of the system forward in logical and discrete steps, which we can follow and justify. This is important when communicating how the system meets stakeholder needs, especially if the result is not what they expect. In addition, following every process reduces errors by progressing the system only in a prescribed way. This in turn reduces risk. Similarly, the need to bridge conceptual gaps in understandable ways is one reason why we might have several levels for each process. For example, the progression from the system requirements to the architecture definition and then to the design definition is recursive. That's because a design, in a sense, is described as or defined as a set of subsystems, each with their own interactions. And these subsystems are then further each defined by their own system requirements. This recursion ends when we can produce something concrete. This is distinct from iteration, where work in one process leads to revisiting an earlier process.
So far, we have outlined what we have done, but why did we feel the need to do it? Looking at the technical processes from the point of view of a systems engineering novice, with some project management experience, it shows that the technical processes as defined in the standard and the handbook focus on how to do the processes, not necessarily on the outcomes of the processes. So why these processes have value can get lost. By defining what changes in the state, maturity or understanding of the system of interest during each of these processes, we reduce confusion about exactly how the processes differ. In our experience, this confusion, as we've mentioned, it typically comes from people without a systems engineering background, particularly where system definition is developed. So they don't understand why they can't jump from requirements to building because they don't understand the processes in sufficient detail. So the work presented so far in this presentation, and definitely in our paper, because that's a lot more detailed, it hopefully makes it clearer what the outcome is for each of the technical processes as defined in the standard and the handbook, and it shows how each process adds value. For example, the architecture definition process and the design definition process, as we've mentioned as our example, often get confused, and viewing them as making well-defined changes to the state of the system, it makes clear how they're very different and they do different things. By focusing on the perspective of state changes within the technical processes, We believe this significantly improves awareness of what each process delivers, and it makes the processes easier to understand. It further makes explicit the value of each of the processes in terms of their outcome. This understanding will also help the systems engineer tailor the processes to their specific system. We believe that by reducing confusion about and showing the value of the systems engineering processes will increase the adoption of systems engineering on projects and programs, which will consequently reduce risk. We've also shared this work more widely, and we shared it with Gary Radler and Dave Walden, who agree that they think there's some significant value in this change of perspective, and they are thinking about how they might include it in the next versions of the standard and the handbook.
In our work, we looked at the technical processes and why each is needed. Thinking in terms of state changes helps us to understand why each process is needed. Each enacts a specific state change. Each of these state changes in turn reflects increasing maturity of the system of interest. We have shown what this means in practice through examples. A consequence of using all the technical processes is that we reduce the conceptual gap between the as-is and the to-be for each process. If we skip or combine processes, this conceptual gap is just too great to comprehend. We have presented an approach that makes use of these ideas to reduce confusion and provide greater clarity, leading to systems that better match the needs of stakeholders. Thank you. I think we can open the floor up to discussion and questions now.
Right, so we've got a question from Sanjeev now. How is the architecture definition of 15288 related to the systems definition of the CSM-RA processes?
Sanjeev, could you explain? Well, I'm not familiar with the term CSM-RA processes.
Good afternoon, everyone. Hello. In the railway industry, we use the common safety method for risk assessment as a process to regulate safety of the whole transition project, which will either introduce a new technology or a new process or organizational change or even human factor elements into the railway process. So what I found in my experience since I began applying the system engineering process since 2006, and also we had an international conference in 2010 where we discussed the system definition aspects and the properties like safety are not handled by INCOSE handbook or even the IEC 15288. There's a huge conceptual gap which is acknowledged by the various learned societies and even RSSB itself that they cannot generate a system definition to address. So if we have an architectural definition, the question is how it will go and relate to the higher stakeholders like the Department for Transport or the ORR and their system definition, how it will relate to your architectural definition.
I'll start that, but I think Liz might be a better place to fill in some of the detail on this. I might be putting her on the spot there. To me, I mean, the safety aspects are not explicitly covered in 15288 because they would form part of the initial requirements for the system, within which the architecture obviously has to be defined. And I'm sure John's going to have something to say on this as well, if he wanted to. But given that Liz and Alexander are working explicitly on HS2, they may have be closer to this. So, to me, I would say, how is the architecture definition related to system definition of any safety or reliability process? It should be because the safety and reliability aspects form part of the requirements to which the architecture definition responds. Liz, do you want to add anything to that?
I fully agree. Any safety practice, any good practice should be set up as part of the requirement set, where relevant, and that the reason it's not particularly explicit within 15288 in the handbook is because they are industry neutral. They don't focus on any particular space for very good reason. It's because systems engineering can apply for pretty much anything, from installing your own kitchen through to building HS2, for example. You know, that's just because that's what I'm doing, but you know, it could be just as easily a battleship. Again, that would have its own set of requirements, particularly around safety and human factors and other bits and pieces, but they would that would be very specific to the project. So they do fit very well together, but how they fit well together is very unique to every single project, and that's where understanding the processes, as we were trying to do, is really valuable. And finding different perspectives and views to help people understand the processes better helps them to interpret them appropriately with the other methods of understanding the world in which you're working. So the common safety method is, and the risk assessment process there is definitely a really powerful tool, but you can use them hand in hand with the tools that are available within the ISO standard for systems engineering and the handbook.
Yeah, and I think that's, so I wouldn't normally answer the question, but as Keith has prompted me to do so, obviously, yeah, I mean, we have to bear in mind that ISO 15288 and all the ISO standards, as Liz has pointed out, are intended to be very, very high level references that can't possibly apply to every type of system. And I think this applies to the, Sanjeev's also asked another question about why soft systems methodology isn't mentioned in 15288. The standards themselves are independent of any specific techniques or methodologies. They're just basically saying, these are the kinds of things you need to think about and the kinds of things you need to do. It's not saying you need to follow these explicitly all the way through. They're not mandatory. It's just a very high level guidance. And I think, as we've seen here, and I think to me, one of the points of the paper is you can take something that's an established best practice model like 15288. You can't take it off the shelf and use it. You need to make it your own. You need to say, well, actually, what does this mean for us? What are the implications for us, and where does the value lie for us? So I think it's a good question, and I think we've had some very good answers.
It's a fabulous question.
Yeah.
I want to say one other thing. Is the one thing we aren't saying is we're not saying that the standard isn't good, and we're not saying that the handbook isn't good. All we're providing is the insight that we started looking at it slightly differently and learned some stuff from it. So this is in addition to, not instead of, is what we're saying.
Yeah, absolutely. And I think that's a really important point to make. But it's a really good question. We need to be thinking about these things. Now, I've had a question handed to me on a piece of paper because I'm actually with somebody today who's been listening to this with me as well. So I've got a question from Simon Perry, and Simon's asking, how is this being rolled out within Costain in itself? Has this now become part of the established Costain process? What's the next step?
This has informed the way we present to our budget holders. That is what this is doing at this point in time. Within HS2 and other projects from key clients like HS2, systems engineering is becoming a contractual requirement, which is a really good thing to find. However, what we do find is that particularly our project management community are less well informed, and when you start talking to them about requirements, you can just see them glaze over. So you kind of have to find a way of, and this is why we were beginning to think about it as well, is we need to find a way of communicating better with our non-systems engineering budget holders about where we add value and why front-end loading for systems engineering is the best way you can spend your money. When actually you're standing there going, just please employ me, is what they hear.
Yeah, and I think just adding to what Liz was saying there, that is really important, because one of the things that we were explicitly trying to do with this series of meetings on this topic was to say, what does this mean for Costain? So Costain has got a systems engineering team, and they are working on building a systems engineering methodology for Costain in infrastructure projects, which is going to be different from a systems engineering for Rolls-Royce building aero engines or Vodafone building communication systems, but still based on the fundamentals of the handbook of 15288. So what does business and mission analysis mean to Costain? Actually, that's something that Costain pretty much did pretty well anyway. But what's the difference between architecture and detailed design for Costain? And as I say, it was only really when we did this work, and I've retired, so I've had a long time doing this, but I really understood the difference between those two processes. And previously, I'd really just thought of the difference as, it's just a different level. You do architecture, and then more detailed is design. Well, what then does that mean? The design of the subsystems is that just even more detailed design. So what's and it really helped me to understand that distinction. And I think, yeah. So shall I come on to so remind me what Simon's question was there again? Sorry.
So how is this now being implemented?
So I think we've answered that. So I think we've covered that, hopefully.
I mean, the flip side is, as we are growing and developing as a systems engineering team and function, we will be using this knowledge and experience and the development of the ideas to tailor our process, to tailor the systems engineering processes effectively to the work and the projects we'll be doing. And Costa work across many sectors. It is all construction, but they work across rail, they work across highways, they work across water and power. Each of those industrial sectors has their own culture and approach to the way things work. There are some common themes, but so we can't put one systems engineering process in there and walk away, because it's not one size fits all. So even for those of us who develop the approach now for the clients we currently have, we will be teaching and encouraging the likes of Alexander, who are our tail coming through, to grow and to learn, so that when they get tasked to make it for a different client in a different sector, it can be tailored and everyone understands how and what and all the other bits. And to answer Sanjeev a little bit about his soft systems methodology, part of that is being better informed about what is new in the world and what is good in the world out there to include, because things do move quite quickly in the world of systems engineering, and different models and methods turn up quite quickly, and they come from all over the place because we are diverse and innovative thinkers. And we go, great idea, pull that in, and everyone goes, ooh, good practice. So it's about making sure we understand it well enough to incorporate the new and don't throw out the old that works.
Yeah. Oh, sorry.
I was just going to say, I've got a bit of almost a cheeky follow-up comment to that, because when I knew you were presenting, there's a question that I've been dying to ask, and I thought, no, but as Liz has inadvertently brought this up, between Costa and Capgemini, I think 95% of all the systems engineers in the UK now work for one of those two companies, with the way that they've been employing people. If you want a new job, they're your options at the moment. So
for us, we're great.
How timely was this piece of work? So because you mentioned, you've got a growing team, so did you reach the point where you said, well, hang on, if we're a small team, we can almost get by without it, but actually as we get bigger and we start to bring more people in with more diverse backgrounds and educations and experiences, you really need to get this stuff sort of battened down now? Was that a consideration, or is that just a coincidence? That
it's a coincidence,
on the
I
global
think,
domination?
to be fair. The global domination has occurred through fortunate and coincidental contract wins, to be honest. We have a need. We have a huge need for systems engineers to support our clients. That is, it's a simple driving force. It is coincidental, but we were already in a position where the client was requesting systems engineering thinking and approaches, and didn't know what they were actually asking for. So we had to work it out so that what it was that we were offering, and B, sell it to our client as well as the bean counter. So that was but fundamentally, Keith was really hit the nail on the head right at the beginning. This was about how do we build a team or keep a team functioning in a world where we've all been sent to the widest corner of the world, which may be the other end of each other's street, doesn't really matter, and keep morale up in a pandemic. And we want to say, talking about something as fundamental as why do we do the job we do is actually a pretty good way with some structure.
Okay.
I mean, you know that the Incosi cafes on the global scale are actually really quite fantastic places to generate some interest and involvement.
Okay, Keith, anything to add on that?
No, I don't think so. I mean, I entirely agree. It was, it was fortuitous in a way. We did direct it. We weren't just talking about the handbook. We had this idea that we would say, what does this mean for Costain as an output from that? But the real reason we had the meetings was to gel the team, really. And it worked very well because, I mean, there are lots of members of the team I've never actually met face to face, Liz or Alexander.
That's probably for the best. So.
For them, yeah. So, but I felt, you know, the team really did gel very well. Probably in some ways, because we were meeting daily, almost better than if I'd been going into the office a couple of times a week when maybe one or two other members of the team might have been there. So it worked very well. So that's what it was.
I think that's a really fascinating point, is actually, you know, without wanting to sound too glib about it, but, you know, systems engineering actually bringing people together in the face of unprecedented world events. And yeah, that's absolutely fascinating. That's not something that immediately leaps out when you think about how do we improve the processes, or, you know, how do we make them work for us. It's actually, yeah, the whole, it's about building a team. It's about people working together to deliver, you know, not in the defense term, but to deliver in the classic sense, a business capability that you can then use to, you know, to further the whole organization. So yeah, really good. So
I would also like to say, weirdly, you say, why are we doing this land grab of all the systems engineers in the world? I think this team build, this discussion, this knowledge share that we did, which was now 2 years ago, has probably grown that potential and that interest, which has actually shown our client and our senior leaders that systems engineering adds a significant amount of value and has a function, has a part to play in the bigger picture. Has actually come from those discussions that were initially just about staying sane. So something as simple as let's talk about our professional development and do a bit of learning while we're all stuck at home for a month, maybe. It became something that's actually grown arms and legs, potentially in a really good way. So we're presenting our thoughts to the wider Incozy world, hopefully to the more, you know, the wider business world. We are a team that's growing. We're a space where hopefully systems engineers are valued and appreciated. So if you're coming from a sector where perhaps you don't have that as much, you know, come and join in the fun. Don't want to pitch everybody. We know there's other things going on, but, you know, it's a place where we can grow more systems engineers as well, because we have a team that can support graduates and apprentices, because there are enough of us. It's not just one person sitting there managing the whole requirement set for, you know, a program on defence, as I've known it in the past. We are actually a supportive function who, you know, so, you know, for example, I've just been asked to, I'm a PRA. I've just been asked to support 3 of my colleagues immediately on an informal basis, but I've also had my first formal request come through. So that's the kind of thing we can offer as a result of the team growing.
Yeah, that's absolutely. This is the direction I thought this talk would go in, but it's absolutely fascinating. It's really, I think that's your paper for this year. Is you know, write up what you did, write down what Liz just said. That's your abstract. So, so very good. So we got we're down to the last sort of minute or two now. So are there any final very quick questions from the floor? Otherwise, we'll start to wrap things up.
Yeah. I'm from a different organisation altogether. It's just starting really with systems engineering. Right, we've got 12 of our people that have done the test, and 2 are CSEP and the rest are ASEPs. Like, we're trying now to, even though the company has been working to systems engineering without really knowing it, right? Is there any tips on how we can sort of get teams together or convince higher management that this is a good thing to do?
Okay, so
I've got an answer
to the speakers. Liz, over to you.
Unless Keith and Alexander want to jump in. First, you say you've got a load of people who've just passed the exam, which is great. You've got loads of people who are familiar with what the handbook says, which is essentially what the standard says, but you do need to read them both because there's subtle differences. Start a discussion group. On all honesty, just start a discussion group. Start talking about the processes, how each of you interprets them slightly differently. Learn about them together. Put the focus on your discussions. How does this add value to your own business or your own project? if you've got a team of 12, you've got an infinite amount of options in there. They will come up with some amazing stuff that they may not even know that they know, but they do. I would thoroughly recommend it. And if you struggle with leading a team or you struggle with leading a meeting, go and do a bit of research on how, because there'll be people that are deep thinking that don't say much, but they'll have some great ideas. So you need to be able to shut people up and pull people in, all of that stuff.
And what we did while we were learning the systems engineering, we formed a group anyway.
Keep it going.
We've been meeting each week, but it's broken up a little bit at the moment because people are very busy on projects. But we'll raise it again. But yeah, we have been doing some of that, and there's one person that is leading it right from the start, which is a senior engineering manager, and he's already been discussing with higher management and things on just how we can take this forward. So thanks. It looks like we're on the right track.
Yeah, as this, I mean, you know, what the way we did it was basically we just once a week someone would present on another of the processes, so that person then would go off and that's all literally how we did it, but with the focus on and what does, well, we were looking at a couple of things, looking at the process itself. We're also looking at, do we already do this in Costain? Do we already have processes on this topic in Costain? What could we change? And if we don't have them, what's the value to people? So very much focused on the business. And then I know I haven't, you know, I left Costain in May last year, but that sort of thing was definitely building up. And Costain, it surprised me when I joined that a company that I thought was someone who dug holes and built roads would be so interested in systems engineering. But it's absolutely fundamental now to the way Costain puts on any bid. And a lot of the customers don't even realize they're asking for systems engineering because they don't use that term, but that's what they want. So if you can do that in your company and get that expertise, and you will have, as Liz said, you'll have in 12 people, you'll pretty much guarantee you've covered the whole field. And some people won't know what they know.
That's right. That's what we've been finding.
Yeah.
In discussions.
Yeah.
Okay.
Great. Good question, Dave. Thank you.
Thanks.
Okay. So, and any more? So we're pretty much hitting the end of our time now. So I'd just like to thank once again our presenters for a fascinating presentation and for an excellent discussion afterwards. It certainly got people thinking. As I said, this will be made available on the INCOSE UK website. The proceedings are available if you'd like to read the full paper. And thanks again, everybody, for joining us. So take care, everybody. Stay safe.
Thank you, everyone, for listening.
Thanks.
Cheers.
Bye.
Bye.